All right, here's the last lesson of Unit 3. It's nice and short. It's just how to divide a polynomial. So we're going to use what we learned in Lesson 1. We're going to take a monomial and divide it by a monomial, or a fraction that has quite a few variables in it. And this obviously indicates division. All fractions are division problems. So we're going to practice how to reduce this fraction. So we have 25 over 5. So that's 5 left over on top, right? I have x to the third over x to the first. That means there's 2 extra x's on top. If you're used to doing it this way, it's x to the third minus 1, right? If there's no exponent there, it's a 1. So this is x squared, which means it goes on top, okay? Then we have z to the 3 minus 1, and that's z to the 2 also on top. And oops, I forgot the y, and there's no y on top, so this remains on the bottom. That's the best I can do. This one has a negative 1 over a positive 1, so that negative is going to stay. We have extra 2 x's on top. We have y to the second minus the second, which is y to the 0, which is a 1. And a 1 minus 1 is a 0, which is a 1 for here. So we end up with an answer that is not a fraction. Okay. And then this one, I have a negative or a negative, which is a positive, but there are no common factors in a 5 and a 12. It looks like I have an extra x here. I have x to the third minus 4 is x to the negative 1, which is this way as an answer, right? You flip it to get rid of the negative exponent. So the x to the first is down here. So that's the same as just putting the x down there. There's an extra x on the bottom. Y to the second. Excuse me. Y to the second. Over y to the first. Pardon me for that. Been making lots of videos. This is my last one. I'm going to get through it. Sorry about that. I think that's it. Okay, and this one, negative 5 over positive 5 is a negative 1, x to the second, z to the 10. So my final answer is negative x to the second, z to the 10. All right, so we practiced. Let's look at our new skill here. Dividing a polynomial by a monomial is done term by term. So each term is divided by the monomial term. The one large fraction is turned into the sum of many fractions. So we have this polynomial here, this 5th degree polynomial. Just to review, its leading term is 9x to the 5th. So it's a 5th degree polynomial. It's the largest exponent here, therefore it's the leading one, just to refresh your memory. So here's my polynomial. Here's my monomial. We're going to divide this, so we need to turn it into a sum of fractions. You take this denominator and put it underneath each term and put pluses in between. All right, so let's just look at this one right here. We have 3, and it's going to be negative, and extra x's on top. Oops, I put a plus, but looking forward, it looks like it's going to be 1 negative again, so this is also a negative. Negative 3 into 6 is negative 2 with 2 extra x's on top. This one is going to be a plus because this is a double negative, and 3 into 18 is 6 and an extra x. Double negative plus 3 into that is 8, and same thing over same thing is a 1, so it's gone. So that is my final answer there. Okay. When you have the same thing over the same thing, it's a 1. If you have a 12 over 12, you have 12 pieces of pizza, and you have all 12 pieces, you have 1 pizza. Okay? Excuse me. Next one. Here's my polynomial, my monomial. Put them into a sum of fractions and reduce. Extra 2, extra x. This is the same thing over the same thing, so that's a 1. And this one's going to be a negative 2 on the bottom, extra x on the bottom, and don't bring it up. Make sure you put a 1 here to hold that down. Okay, this is going to be a plus. It's also going to be a fraction. We're going to reduce by 2, and that just stays there. So look at how these look. They're just, you just go with it. You can have fractions and whole numbers, and it is what it is. Okay, so let's practice a few, and then we'll be done. So x to the 4th over 4x3. X to the 3rd over 4x3. 2x squared. I'm showing all my work here. This is an extra x on top, but a 4 underneath. These go away, but the 4 is on the bottom. It's got to stay there. 2 on the bottom, an extra x on the bottom, keep it there. So that one looks like that. This one, another way to do this is just kind of put this underneath. Oops. And then this is 5 over 9. That's not going anywhere. No common factors. Extra x's on top, and the y's are the same, so they're gone. Negative over positive is a negative. 9 into 45 is a 5x. 2 extra x's and the y's are gone. So that's a whole number. It's over 1, but you don't type it that way. Negative over positive is 2x y to the 3rd. I got that right. Double check. Yep. So that's that answer. And this one here, got all kinds of letters going on, so I'm going to try to be careful. I may just write them separately so I don't mess it up. All right, so this one is a negative. You can put the negative out front. Once, if you have just one negative, it can go here, 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 or here. So just put it out front. And we have x's, extra x's. We have no y's, and we have a z. So that's that one. Then we have 4x squared z squared negative 8xy squared z2. So that's going to be a negative, one negative, so makes it a negative. And reduce makes it a 2. Then I have 2 x's on top, 1 on the bottom, so that leaves me an x. The y's stay, and the z's are gone. So that's that one. Excuse me. And then I have negative 8y2 over negative 8xy2 z2. So same thing over same thing is positive. Double negative is positive. X's are gone, Y's are gone, and the Z's on the bottom. So that's the strange answer. That's that one. Hope this is helpful.